So that's BBKZZL.
Go again, sorry.
I've got to get a multi-key. And have you looked at that process? If you go to the M side, mate, I've got to get it done by any idea?
You probably saw my email about Josh. Yeah, what a shame. Well, it's not a shame because he's coming next week. You probably know what he's doing. He's got some manufacturing issues.
Could be that.
Well, we can still talk about the assignment a bit. Right, what I want to talk about this week, really, then, is a continuation of introduction to machine vision and the kind of things you're going to be doing in LabVIEW. Is the LabVIEW going okay?
Yeah.
You guys getting into it, Colette and everything?
We added 2 numbers together.
Oh, right, well, that's the start, isn't it? I mean, no, it's quite fun.
Sorry, can we have the code again? I missed it last time.
Yeah, the code is BBKZZL. So anyway, yeah, sorry, I'll talk about the assignment in a minute, later on in a bit, if you like, and we'll talk about that a bit. Now, this is like the classic machine vision stuff I'm talking about here, you know, what we were coming from over the years with machine vision. I think the first ever application, right, for machine vision in industry was Ford Motor Company, and it was a clip on the end of a crankshaft. If you don't have the clip on, you're in serious trouble, but it's a very boring job checking it's on there, that kind of thing. So, special objects that are critical, but a bit dull and repetitive. Measuring distances and angles, examining objects. I'm not going to read all this out, I think it's pretty self-explanatory, but if you've got any questions, give me a shout. Positioning, yeah. Detection. Yeah, another thing you could talk, talking about DVDs there, another thing you could do is, of course, check the surface of the DVD. Check the surface has no scratches on it. And a lot of these manufacturers do polishing operations to get rid of the scratches. Can anybody remember a machine vision technique it might be useful for doing something like looking at the scratches on a DVD? From a week or two ago I was talking about.
Photometric stereo.
Yeah, it's good, wasn't it? Photometric stereo. Photometric stereo I'll talk about quite a bit in future weeks. Right? But it wouldn't be particularly good at that, actually. It wouldn't be brilliant at that. Because photometric stereo, right, assumes the surface is matte, actually. So the light coming down, it assumes it's reflected equally in all directions. That's okay, and that's useful a lot of the time, but that's not really the case with the DVD, is it really? I mean, if you've got a DVD, and what would you do? If I gave you a DVD and said, is this scratched, what would you do with it?
Polish it with toothpaste
Yeah.
to remove the scratch.
Well, how do you know if it's scratched or not? I might be lying.
You look at it like that.
Yeah, you look at it like that. So what do you do when you do that?
Try and get the light on.
You get in the light, aren't
It's
you?
reflecting in certain ways, so you can actually see anything.
You're looking at an image, a specular type, mirror type reflection off the top of the DVD of the light, right? So that is, that in machine vision is called bright field illumination, really, okay? You're looking at a specular reflection, a mirror type reflection off a surface of an extended light source. And what would a defect look like in that image? A scratch, say.
Dark spot.
Yeah, why is it dark?
Because it's reflecting the light in a different direction.
Yeah, it's scattering it, isn't it? It's not reflecting it like a mirror, is it? So that's bright field illumination, and that is used, and we used that, I remember years ago I talked about it, we did a project on polished stone. So these Italians and guys and it was also Greek, Portuguese guys involved. A polished stone, so always get virtually impossible jobs, you know. A huge slab of polished stone, granite or something, it's got all this complexity, all this, you know, God knows how much complexity. You're trying to measure a tiny little scratch on it. And we use bright field illumination. What do you need, by the way, to get bright field illumination working then? Apart from the camera, I suppose.
Bright light.
Yeah, what kind of light?
Monochromatic.
No, it doesn't have to be. It doesn't have to be monochromatic. Could be any kind of frequency, really.
Visible.
Hey?
Visible.
Yeah, help if it's visible, wouldn't it? Oh, you mean you could be
Could be X-rays.
You could use X-rays, right? But if we're looking for surface scratches, An X-ray is not going to be reflected, is it? It's just going to be absorbed. Jeez, it's going to be absorbed in there, isn't it? So you probably wouldn't use X-rays, right? Or gamma rays or anything like that. Right? You probably keep it simple, I say. Keep it simple. So just use these lights, and what we did, just use these lights. But why are they particularly good for this? I mean, the point I was trying to get to is you need an extended source for that, because you need to look at. Do you know what I mean? You're looking at this line along the stone. You're looking at different positions on the line. You have to look at different positions on the light. So a fluorescent tube is particularly good for that. But we couldn't use any old fluorescent tube, as a matter of fact. We had to use. Does anybody imagine why we couldn't use any old fluorescent tube? I don't want to get you to try and guess my mind, but there's a reason we couldn't just use any old tube that we get down the shop, down B&Q.
Some of the older, less good ones, they flicker and they go ting, 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 ting.
That is true. That is true. And that's kind of the answer. It's not. I wasn't necessarily thinking of old ones. They all flicker, actually. They all flicker, don't they? Because the electricity is going at 50 hertz. These things are flashing on and off quite a lot. We can't see it because it's above our range. But that will screw the camera up, if it's flashing on and off. So we had to build special tubes that flashed up thousands of hertz rather than sort of going on off. But I'm just getting ahead of myself with all this stuff. All right. Well, if you've got a question, give it. Yeah, as I say. Well, this diagram's not brilliant, is it? Measurement, examination. Okay. A lot of time looking for medicine in. We're trying to get a project up together with the NHS at the moment, looking at checking people are taking their medicine. Right. So rather than, in this case, a simple example of just whether the pill's in the capsule, but take it further, right? Can we have cameras looking at people taking medicine to see whether they're actually taking their medicine when they should? This is where deep learning comes in, because you can interpret what they're doing. This is the kind of thing you can do with deep learning. Did you know there's shops in San Francisco where you just walk? I don't know about London, but in San Francisco you can just walk in, take some off the shelf, walk out, and that's it. You got it. Oh yeah. Did you know that? Is there one in Camden town?
Yeah, Amazon.
But what I'm talking about, it's not messing around with the phone.
No, you literally just walk in. No, that's
That's it. So you've got systems in like Camden Town. Just walk in. People might think you're shoplifting, but you're just doing the Amazon shopping too. You can do the same with taking pills. Very important. You can do audits. So simple stuff you can do. Checking stuff is there. Measuring angles, directions. What can
And they know if you hover, don't pick it up, pick another brand. And that goes back into their algorithm and they say why did he want that one.
What's that? You got something going on there? Wait a minute, we got a contribution here.
With the Amazon shopping where you can just pick the stuff off the shelves,
Yeah.
if you hover in front of one item but don't pick it up and choose another brand, that goes back into the algorithm and they'll start asking why did he not choose that one, why did he choose that one.
Yeah, it turns out you just pick them off together. Yeah, I know what you're saying. So it's gathering information all the time to try and build up the database of what people's behaviours, shopping behaviours. That's a good point. That is a good point. We just got a contribution here. Ross, is it?
Yes, Ross. Yes.
I'm not a terrible name, so it's Ross here. Has got a contribution about the Camden shop. Do you want to say it again?
Just if you're in the shop and you're about to take something off the shelf, but you change your mind and then you choose another rival brand, that goes back into the algorithm and they're sort of working out what your shopping behaviours are.
That's a good point. And we've done work with retailers, and that's the kind of thing they want us to do. They want to monitor behaviours in the shop. They want to know what shoppers are up to and why they do various things. That's the main thing for them, really. So that would be very useful. It's like Tesla, isn't it? Recording all the time information from cars, just so they use it to build up the database and the deep learning that they've got going on. But that's definitely a deep learning kind of thing. Anyway, coming back to where the history is getting into the traditional machine vision. I sometimes put a question like, what is the importance of machine learning? What is the importance of machine learning? I often put a question like that, right? Which you might think is some kind of philosophical thing, but it's an area which is underestimated, it's not covered much in books or traditional materials. Okay, so it's actually the most important area in machine vision. As we said, things like shadows can really screw things up. Yeah, things that you might think are simple are actually complicated. Like we did a lot of work for a security company on platforms, right? And when the train comes in, that really causes loads of confusion, because it changes the light and you get shadows all over the place. There was a famous case in the Grand Central Station where someone left a bag on the platform and they didn't recognise it. So that's where 3D vision comes in. You can differentiate between things like a dangerous thing like a bag and a harmless thing like a shadow. But shadows are quite a problem in machine vision sometimes. You can investigate this in your image capture. You can have the shadows, turn different LEDs on, all the rest of it. Now, here's the sort of thing you've got to worry about. Is it moving? What sort of, what type of object you're trying to... Now, this is a bit out of date. Sorry about the slides, a little bit older. But the kind of nowadays I put LED at the top. Everybody's using LEDs. It's all about LEDs. What advantages was halogen have over LED?
What was that?
What advantage would a halogen light might offer over an LED sometimes? You know, a couple of years ago, I had one of these sessions, and I got a guy in from Scorpion Vision. It was a friend of mine, and he was trying to do something. And he had a lamp, right? And you know these lights you can get. Is it U13 or what they call? You've got bayonet thing and spotlights, LEDs you buy for the kitchen. We had one of them, and it was an LED. But it turned out I had about 100 of these halogen ones at home. I didn't bring any in. I thought nobody in the right mind's going to use it. But he was trying to image a particular part of the wavelength which wasn't visible in that LED, because the LED didn't give any light to that wavelength. So he screwed completely, you know. So he couldn't demonstrate because he just didn't happen to have he realised he should have had a halogen lamp. So it turns out halogen can be useful then because you've got the entire wavelength, the entire wavelength spectrum rather. If you want a wavelength which is a little unusual, it's there, it's in the spectrum from the halogen bulb. These have all got advantages and disadvantages, okay? Laser, anybody think of an advantage of that?
One wavelength.
Aye?
One wavelength.
Could be, could be. Monochromatic. Could be useful. What else?
Polarised lasers.
They're not exactly polarised, right? But they are coherent. They are temporally and spatially coherent. It means, does anybody do physics, like A-level physics, right?
Yeah.
You did it. Well, you know what coherent is.
Very, very long time ago.
Yeah, you know you've got the wavelength, right, of the light. It's in phase, is what coherent is. It's all in phase. That can have a disadvantage, actually, if you're using lasers to illuminate things. Has anybody heard of speckle pattern?
Yeah.
You heard of that? Well, that's due to the coherence of the laser. And it's a weird effect due to interference effect. But it's generally speaking a disadvantage. But some people do use it for things like you can measure, you can do things with it a bit. But generally speaking, it's a bit of a disadvantage. It might limit the accuracy with which you could do laser triangulation, right? And I'm going to talk about laser triangulation a bit later on. But what else? Fluorescent, we talked about that a minute ago. Okay, this is all right. Oh, look at all this text. It's too much here for me. This is a straightforward situation. What we're trying to do in classic machine vision then is get something in the foreground of interest, differentiated, if you like, by as many grey levels as possible from the background. If I want a box and try to measure it, I want probably want a bright top of the box and a dark floor or something like that. Did a project for a company in the States, measuring boxes for US Postal Service. Got it working. Took it over there. We used shadows actually, shadow measurement. Okay, anybody got any questions about this? Sometimes you get a problem with highlighting. Specular means mirror light. You've got a reflection off the coating, maybe it's in a plastic wrap or something that can cause problems. Now, okay, ring lighting, you know all about that, right? A ring of LEDs around the camera normally, or something like that. Backlighting you will do in the assignment. Now, has anybody gone over to the lab?
No, but I emailed him and he never got back to me.
Well, he doesn't necessarily get back to you. Honestly, he didn't get back to me all the time, but he's a great guy. He's a fantastic guy. Have you met him?
Well, no, because I said, when shall I come down? And I'm waiting for him to reply.
What he does, he'll probably do something brilliant for you, sort it all
Oh,
out.
where were you last week? Because I want to collect into the thing.
Yeah, I forgot that you were going to go down there.
But the fact
They took
is,
us all down there last week.
you were down
You're
there.
not doing
No,
the-
they took, she took us all from the tutorial session.
I went to
Last
that.
minute that we went to the lab and saw the kind of equipment and stuff.
Was that with me?
No,
Oh, well, go on.
with Colette.
Oh,
It
yeah.
was interesting.
Yeah.
Kind of took us through how it all works and showed us the kind of dummy grub screws.
Yeah.
Seems right.
Yeah, it's a real problem.
Further comment?
No, it's a real problem.
Okay,
I mean,
it's too much.
I think Josh is going to be good when he comes in next week.
No, it's
Josh.
actually this way. Here's where the camera.
No.
Here's what stopped
You got, okay, let's get this straight. You've got to, you've got to go to the lab. You've got to go to the lab. But the thing is, when you go to the lab, you will see, okay, a load of cells. You saw this with Colette.
Yeah.
Now the one on the left, right, is probably the one you're going to use. That's one, number one. That's checking the type of lighting. Right? And did you see the little backlighting thing?
Yes.
Yeah.
Is that on, was it?
Yeah,
Okay.
it was, even though it was so small but so bright.
Yeah, I got these glasses which these glasses I strongly recommend putting them on before you turn any.
Oh, yeah.
Because they're pretty good. These are pretty high quality. And the fact is, you will get a nice silhouette with the backlighting, right? Which I think is brilliant, actually. I think Colette's keen on the front lighting. I think the backlighting. You want to try both. Try the backlighting, try the front lighting. What's the advantage, disadvantage? Get some good images. You know, then you can use them in LabVIEW for doing the actual assignment. So there's nothing stopping you going in there and doing that. I'm having a little bit of trouble, I've got to admit, with the aircraft door at the moment, for reasons I won't go into. But I'm hoping to sort that out pretty fast. So the thing is, you can go into the lab, drop him an email. If you dropped him one and he didn't get back, you could probably just go down there at some point. And you, could, you know, he may not be available then, but you'll be able to set up it. I said to him, just keep everything as simple as possible. So he's going to put it on Outlook when he can do it with you. So, yeah, he's great. He's fantastic. He's rigged up. What has he done? Every time I see him, he's rigged something new up for the lab. You know. And then he'll spend all his time on the bloody flight simulators and car driving stuff. You're not careful. Anyway, let's get back to this. Now, the importance of lighting. I've talked about this again. Backlighting, V-lighting. You know this. If you've got questions, chat. Now, this is worth. We're about strobe lighting. I don't know, it's a little bit, I told you last week, you probably don't need it actually, nowadays. Why don't you need it?
Because you can have a really high shutter speed on your camera.
Yeah, exactly,
So you can just have constant light.
exactly, yeah. Bright lights, just take an image when you want to. You know, years ago, it was such a pain in the ass. I mean, 20 years ago, you didn't have any of this electronic shutter stuff. You had little dip switches on the back of the camera. That was how you adjusted the shutter. Nowadays you do it all in software. So you do it all in software, and what about from the lighting point of view?
You just keep constant light on.
Well, you want to save energy, you know, being that, you know, war going on and stuff, you probably want to save energy. You just, with LEDs, you can turn them on and off very fast. So you just turn them on when you're taking an image if you want to. Or you can keep them on all the time, they're quite efficient, you know. So, you know, you can do it all with the camera and the LEDs now, with the strobe lighting situation. You see, if you've got an LED and you're running it just for a short period of time, you can run it at a very high power, overpower, because you haven't got a chance to overheat when you're running for a short time. Now, so you get your image. The lighting and sensor specular response is worth worrying about, because this, I don't know how happened to this figure, why it's two lines, meant to be one, I think, but this is showing the efficiency of the sensor, right, for different wavelengths of light, for different cameras. So, is everybody okay with that? You know, when we did this project I told you about a couple of weeks ago, when we first project we did in the year 2000 for measuring objects for a company in Salt Lake, we actually got a camera that had an extended IR response. In other words, it was sensitive in the infrared because we were using light that was kind of this kind of wavelength. It was very long wavelength. You want to really to get good, you know, sensitivity in the wavelength you use it, really, to get a decent signal to noise ratio. Look at this here. This one here, this camera here, has got this IR cutoff filter. Can anybody imagine why anybody would want to put an IR cutoff filter into a camera?
So you're getting the wavelength that you want.
Yeah, but what is an IR cutoff filter?
You get rid of the infrared light.
Yeah.
Maybe that through.
It blocks the infrared light. And it turns out that camera manufacturers used to put these things into cameras. I don't know, it's right nuisance. But they were only really doing it to simulate human vision. Sony did it. So we had to spend a load of time and effort on getting the filters out, buying block dummy filters that didn't do it, inserting them, and you can't just take them out because it might affect the quality of the image. Anyway, nowadays you probably wouldn't have to worry, but I think they got over that crazy idea of putting dummy filters in, really. But you do want a response. So when you're buying a camera for a certain application, you want to make sure it's got sensitivity in the range you're interested in. Nanometers, say. And yeah, they've got to talk about the IR cutoff filter there. Yeah, and you know, sometimes infrared light is good in machine vision a lot of the time. I mean, it can be useful in various applications. I talked about photometric stereo, we'll talk about it again. It works better in infrared light than it does in visible light. I think I talked about this a couple of weeks ago. I don't know if you remember that. I can talk about it again if you want. Yeah, so, you know, supposing, can anybody think of any application, I don't know, any applications in food processing you might want to use infrared light? Supposing I've got a load of apples coming along a conveyor belt. This is what I've got in Somerset. I'm absolutely overloaded with these apples now. But what if I was working out the quality of these apples? Has anybody got an idea about what you might be able to do, happen to know, in terms of checking the quality of these apples? It's not a fair question, is it, really? Unless you're into messing around with apples, you want to necessarily know the answer to that, would you?
You look at the colour of it?
Yeah, kind of, yeah.
Yeah, well, how do you define the quality of an apple?
Well, in my case, you know, I'm sitting out in the garden, right, and I'm hearing this bang bang all the time, right? Well, these apples are falling off the tree. Like,
Can you look for bruises?
Exactly.
Like that with infrared.
yeah, exactly. That's exactly it. If I've got a lot of Granny Smiths, and to be honest with you, Granny Smiths, right? They look they're pretty robust, right? These apples, and they look all right, even if they got a bruise on them, invisible light. But infrared, the bruise will show up. Turns out. So food processors will use infrared for checking that kind of thing. Looking for glare, shadows, looking for the glare and shadows. Now, a lot of the time, as it says there, you can use special lighting filters or lenses. Yeah, you can buy all this kind of thing for scorpion vision, stemmer vision. But, you know, supposing, did I mention last year, does anybody know anything about laser triangulation? Who knows anything about laser triangulation? You know something about it, right?
I very briefly covered it in Flash and stuff.
What does it involve?
Just finding the height of stuff.
Yeah, but how?
Lasers in a set location, it shines the laser on it, and then where the kind of gap bonds between where the camera might sit to measure the height.
Yeah, the laser impinges on an object like a box or something.
Yeah.
And because the box is obviously higher than the floor, the distortion in the laser line lets you work out the height of the box at each point. Now that is a brilliant technique. It's used all the time. The system's all the time available to measure things with laser triangulation, and use it in industry all the time, maybe on conveyor belts. But supposing I'm kicking around with my laser triangulation system on the conveyor system, what have I got to deal with? What issues might I have to deal with in the factory?
Something blocks it.
Or somebody puts something in the way?
Yeah.
Could be, I suppose. Could be.
Cockroach crawls in front of it.
Could be.
Like an uneven surface. Because if the surface of the camera that's uneven, it will distort it even more if I
Yeah, it's interesting. You know, if the surface doesn't change, that's not a problem. You can calibrate it. But if the surface is moving around, it's like one time, right? And I say this because I'm thinking of it now. I was working with a guy in Spain doing some work on measuring steel billet coming off a mill at a high temperature. And he was using laser triangulation. He was measuring steel billets. This is going along, bouncing around on a conveyor belt, right? Well, it's moving around. It's moving down a conveyor belt. This probably, talking about uneven floor, is kind of what was happening there because the conveyor belt was vibrating a bit. And he was having this problem for getting errors due to this. And he said to me, what can we do? And I said to him, put another laser triangulation on it, put another laser on it. And he actually got it working in a published paper. He put my name on the paper because of that. So I'm kind of chuffed with. Nice guy, great guy. But no, why is that going to work? Possibly.
You can find an average between the two lasers. So if it's moving more in one and less in the other, you can work out. You can see this. Not, I don't know.
Yeah, it's basically finding, if there's something going wrong with the conveyor and it moves up, it will move up in both the images. It gives you a means of measuring movement versus size of the thing you're talking about. It's like we had another that American project I was telling you about. We did the Salt Lake thing. That was laser triangulation. We developed a laser triangulation system from scratch. We couldn't buy it. We had to build it. So I had this laser scanning across 5 meters up in the air. The signal that came off it, we looked for a differential in the signal rather than just measuring a voltage. We looked for a difference in two voltages rather than just measuring a voltage. Give us a position of the laser, right? But can you imagine why we did that? Just measuring a difference in the voltages rather than just simply a voltage. It's a similar kind of thing. If there was a little blip in the voltage supply, the power supply, then even if there was a blip, the difference would remain the same. But the absolute voltage would change with the blip, possibly. So it's a way of reducing errors and noise and that kind of thing with systems. So this equation I put up now that's probably the most important thing we ever going to see in machine vision, actually. Because if you get onto the shop floor and someone wants a system set up, this is what you've got to start thinking about. It's actually a very simple equation, just a bit of geometry. Minimum field of view equals sensor size times the D, minimum focal distance divided by the focal length. So, whenever you're working on it, you want a certain field of view at a certain distance, this is what you're thinking of. With this, right, if I've got a certain object at a certain distance, I don't know if I mentioned this last week, but I can either get a lens with a long focal length, with a big sensor, right, or I could get a lens with a smaller focal length, with a smaller sensor. It depends on the application. What's an advantage of having a longer focal length?
Less distortion.
Yeah, less distortion in the image. Less barrel distortion. I talked about this last week. What's an advantage of having a small sensor?
Can you focus on one particular thing?
You do what?
Can you focus on one particular thing?
Well, a smaller sensor will give you a...
Less expensive camera.
Yeah, exactly, that's it. Yeah, it's just cheaper. Cheaper, basically. There was a big fashion towards cheapy little cameras. I think they've gone back to bigger sensors now, thank God, because we used to have these little... because a lot of sensors, if you use them out in security applications, they're good enough, But if you're using them in metrology, with laser scanning, you don't want distortions and such. Yeah, so nowadays, thank God, they're also getting square pixels. There used to be a fashion for rectangular pixels, which was a real pain, but nowadays looking at larger sensors and so that's your little equation and your diagram and such. Now you've got to think of a few things about it. You've got to think about the mount that the camera is being mounted to the camera on. And the camera has to be designed, really, for a sensor of a certain size. Like if I have a camera that's got too small a mount, and it's designed for a smaller sensor, I might get some errors in the image. What do you think I might end up with if I'm not careful? Nobody can anybody imagine. The mount thing is this is a C mount lens. When you've got an SLR, you've got an F mount. So obviously C mount's cheaper. But what I was thinking of is vignetting effect, like they used to have in Victorian pictures, where you lose the exterior sort of, or you might have poor, it may just not work properly. So you want to make sure that the lens is suited to the camera. And to be honest with you, it's a little bit of a black art. This is where scope vision and stemma vision come in, so I help you get a decent combination of a lens and a camera, really. But Tamron, for example, is a Japanese manufacturer making middle of the range lenses made for £100 a go. Schneider is a German operation, which is top of the range, so £500 to £600 typically for a lens. Usually I spend about £600 on a lens because you don't want to be cheap on the lens side. Okay? But occasionally you will find a cheaper lens works better than a dear one. Yeah. So we can adjust your aperture, your focus, and so on and so forth. That's your lens situation. Now we've got to grab the image. This is all pretty straightforward. Triggering, right? You all know what that is? Smart cameras. Now, who was it was trying to sell me a smart camera? Oh yeah, Hikvision, Scorpion. I mean, they're great, but they got all these smart cameras coming from China. And does anybody happen to know what a smart camera is?
No.
Well, a smart camera's got like a processor built into it, and so you can do just all sorts of things on a smart camera. Not much you can't do, to be honest with you. And so there's a lot of debate about, when you've got, say, security cameras, there's a lot of debate whether you should have lots of smart cameras or lots of conventional cameras all connected together to some kind of central PC or something like that. You could even do deep learning type stuff on a smart camera, the right kind of USB stick, actually. But we don't use them much because we want to control everything ourselves. This must be some kind of history thing here I put in here, just I talked about it last week. Years ago we used to have to mess around with analog cameras, TV standards. I got a friend who's an electrician who said that NTSC, never the same colour twice, or something he told me about. I think PAL was better, okay, that's my personal feeling. But it was TV standards years ago, so you used to get 25 full frames a second in the UK. And right pain, actually, right nuisance. You know, you wouldn't believe it really, would you? They invented CCDs, charge coupled device, digital techniques, right? And then you had your CCD in your camera, and then you had a digital to analog converter, converted to a TV standard, send it along coaxial cable, then have a frame grabber converting it from analog back into digital. Can you imagine that? But what's the problem with that? I mean, what disadvantages has that got?
I'll show you some quality if you keep changing it
Yeah.
around.
Well, you know, when you've got the analog bit, that's a good opportunity to get some noise in this. Yeah, you lose the quality. Can anybody think of any possible advantage, slight advantage of it?
What, of doing all conversions?
No, just having an analog system. And nobody in their right mind would do it nowadays. Right? But I just wondered if you could think of anything that was a slight advantage at the time of it, or around that time. That stone polishing project, when the Italian partner was doing that, had analog cameras, you know, I was a bit astonished about it. This was years ago, mind you.
Is there less processing time with that analog?
Not necessarily, really. Well, the only slight advantage of it is you know you're going to get 25 full frames a second, and you know what the resolution is going to be. Nowadays, you get anything you want, depending on what people want to do. You know? Anyway, you don't have to worry about it. I'm not going to, honestly, in the exam, ask you about analog stuff, I don't think. Nowadays, everybody's using digital cameras. Now, we've got all sorts of advantages, better accuracy, better super-to-noise ratio. That's an example that you can put it straight on the circuit board, of course, like that. We do that quite a lot. Something like a Raspberry Pi. We're doing this quite a lot in the lab, putting cameras onto you could rig up a photometric stereo rig for virtually no money. You know, it doesn't work as well as the proper equipment, but it works pretty well. You know. And you can compare it. So that's pretty self-explanatory. And this, again, you don't have to worry too much about this, really, because nowadays, I've got to say that technology's come on, and CMOS is pretty good, pretty good. If you're going to buy a top-of-the-range SLR, digital, you know, SLR, you're going to have a CMOS chip in it. But I'm always a bit biased. It took me a while to get into that idea, because years ago, I bought a camera for a photometric stereo rig we were building, and I spent $7.5 grand on the camera. It was German. Now, all this noise in the picture. And I said, what's it going on? And they told us, oh, that's it, you know, that's it. This was years ago. CMOS cameras used to be noisy. And if you've got a technique like photometric stereo which compares images, that can really mess you up. But nowadays, probably everybody's using CMOS, the technology. Maybe astronomers stick with CCD to keep the noise levels down and get a very quality image or something. But, you know, your phones would all have CMOS sensors in them, pretty sure. Now, interfacing to the PC, I think I might have talked about this before. I don't know why they just don't stick with USB. You know. What's going on? You know, USB 4, they haven't really got them on cameras yet, but 40 gig a second. 40 gig a second. I mean, you know, Scorpion lent me a camera which is fantastic. It cost £8 grand. Fantastic, 31 megabytes, great big camera, lovely pictures, real high resolution. But it's a gig E connection. So you can only get about 5 images out of a second. But he told me they're going to get gig 10 going on this thing. Gig 10 is 10 times faster. So we're going to get 50 images a second or more. There are other things you might hear of, like camera link. Nowadays, I doubt if you bother, because you've got to spend 1,500 quid on the card, in the computer for that. Coax Express is a high-speed I don't know why you want to bother with that though, considering that you've got faster speed off USB 4, so I don't know if that's really going to catch on that one. Now the other thing I want to talk about a little bit in this lecture is line scan, because it's an important technique which you'll probably see in the industry. If you ever get into machine vision in a company, you probably find that they're using line scan, they want to use line scan. But yeah, it's good for things that are moving along conveyor belts. I'll say that much. You know, we've done quite a lot of work with it. What's the difference between this and a normal camera? And what's this camera here? This is a line scan camera.
It takes a one-dimensional image.
Does
it take up a one-dimensional image?
Yeah, it's only got a line of pixels in it. Sometimes it can have more, but generally it's only got a line of pixels in it. One single line of pixels. So that's it. When he's talking about capturing a frame, that's what he's talking about, just a line of pixels. Now that stone polishing thing I was talking about, that was good. We used line scanning on that because it was coming along a conveyor belt with some polished stone. This was years ago, but we had an 8,000 line sensor, so 8,000 pixels in a line. Okay. Now the way the thing works is that it takes a line, the conveyor moves a bit, it takes another line, it keeps doing that. Okay, and you build up an image like by combining these lines. You know, that's one capture of a line there. Keep doing that, you build up the actual shape. Now, doing that doesn't sound too bad, right? But actually it can be a bit complicated in my experience, because what you need to do that is what you need to do that?
To move the conveyor belt at a constant speed?
Yeah. Suppose the conveyor belt is a bit old, and it doesn't work particularly brilliantly at a constant speed. What do you need to do then?
You have to pan the camera to match the speed of the. If the conveyor belt slowed down, you have to move the camera back. If it's sped up, you have to move it forward.
What, moving the camera?
Just like tilting it up and down as the conveyor belt's moving underneath it.
Electro-optics. No, electromechanics. You've got tilting it up and down.
Yeah.
It's fantastic. It's a little bit more complicated. I don't want to get into it. It's a little bit more complicated. Is there a simpler way of dealing with it?
Programming like a delay. So if it's got.
How do you know what the delay should be? In fact, in your idea, how do you know how much to tilt the camera?
You'd have some way of measuring the speed of the belt.
Yeah, which is what?
You could have like a ticker tape with a laser going through the.
It's ideal. All these ideas. This is non-linear, right? It's brilliant. Yeah, you could have ticker tape, but there's an even simpler way of doing it. Do you happen to know in industry if you want to measure something that's moving, how you might do it, or how you would measure some rotating things?
Measure the rotations per minute of one of the rollers that the belt's going over?
Yeah, but how?
With a tachometer, but a small one.
Well, all I was thinking of was an encoder. Right?
Yes.
An encoder is a device which will give you a pulse, however many you want, when it rotates. And so all you need to do is measure these pulses and you know how far it's moved. So if you synchronize the image capture with the pulses, then you slow down the image capture if the conveyor slows down. So this avoids distortions in theory, right? In the image, even if the conveyor is changing speed. And that's what's done. You would never get line scanning without an encoder, because you'd have a spad enough with one, But so in my opinion, this is a disadvantage of it. You need the encoder and all this. You need, the problem is you've got Stemmer sending you the frame grabber in here. You've got somebody else selling you the cameras, and it's all done in a slightly different way. Sometimes, it can take months literally to get it working, which is ridiculous. It's relatively simple. Just get an image capture, it takes you months. They don't necessarily talk to each other, these suppliers, much either. So, like LabVIEW, I bought when we were doing this in banknotes. I'm not meant to talk about it, it's banknotes. And I was looking at so we had the encoder and so on, but the frame grabbers were designed for work with LabVIEW, because that's what we were using. But then the camera was a different thing altogether. Triggering it took ages. But why would anybody in their right mind bother with all this? What advantage might this offer?
You don't have to pay someone to do it. You'd have to pay a human to do this otherwise.
Yeah, but I could have a normal camera, an area scan camera, a normal one is, a normal camera, rigged up above the conveyor, and just keep taking images every once in a while when the thing moves by. But this thing takes a line at a time and builds the images up. Is there what advantages has that got over just taking the... What I was thinking of is that there's less lens distortion actually, because when you get to the corner of the image, you get more distortion than you do along a line. And also, what is really important is that the lighting is repeatable. The lighting between these lines doesn't change in theory, it's just illuminated along the line. You could have a line light shining down there. You normally have a line light shining down LEDs, and that's synchronized with the encoder as well, so it just flashes when the image has been taken. So the image is more standard because the lighting and the distortion is less. So whenever you've got web type materials, if you're making paper, if you're making stuff that's coming along continuously, you would certainly probably use it, it's very likely you use this technique. And to be honest with you, it's very commonly used in industry a lot, really. But I think it's worth, the technique that I keep going on about, photometric stereo, we invented a sort of way of doing it with line scanning, which is called dynamic photometric stereo. And we published some papers on it years ago, actually. And I will put the papers on there, so you can reference that. But, and then you can get 3D data from the objects in real time as they move along a conveyor belt. Particularly good for things where you're looking for textures, like banknotes, actually, for example. And so on. Any questions about any of that? So you can get cameras that are sensitive in different frequencies, surprisingly. You can even get shortwave infrared, which will penetrate through certain materials. You can check what's going on inside opaque plastics with these special cameras. Nowadays they're getting cheaper as well. They used to be expensive, these cameras. There we go. But so that's sort of continuing the machine vision. Do you want me to talk a little bit about the assignment? Okay. So you've all looked at the assignment, right? And so I read this assignment. I thought I'd better start mentioning scorpions since they gave us all this kit. So I started changing it and putting scorpion in there. The usual stuff. Don't leave it to the last minute or submit. Let's try and get on top of it. I think I'll probably end up with me marking the essay paper, collet at the eye. And what I think is good about this is that it's a real problem that Josh has got over there. I mean, he came over. We went over there. He showed us the robot. And there's the high-speed chuck. Hamer balancing machine. He shows that operating. And there's an example of the gun screw.
If we work out this problem, who owns the idea? Do they pay us for it, or do they just use it for free?
Jesus Christ.
Yeah, I want some dollars.
Yeah, we can
I think it's a fictional problem, just because it's coursework.
During our employment.
I think they probably already sold it in a way.
Yeah.
Just changed it.
You are students, right? So you don't work for UWE, so the UWEs have no claim on anything you invent. When it gets into, I don't get into IP generally speaking because it's such a hell of a morass. But as a student, you would tend to own whatever you invent.
So invention at home.
That's it.
I've no idea what GKN, I mean, Josh is a representative of GKN, so he should talk about anything like this, but, so I don't know what their attitude is on things like that. But as far as UWE is concerned, we don't have, so many people who work for UWE, we have a claim on the IP for. So that's all I can advise really.
But it is a genuine problem that they haven't solved themselves there.
Yeah.
Right.
Yeah. I mean, you know what companies are like? We deal with them all the time. They're very, very sensitive about anything to do with their problems and their. That's why I put this past Josh for releasing it. He changed a few things. So I don't know what he wants to say or how much he wants to go into the issues they've got and how public he wants to make any of that. But from my point of view, it's just an example problem. Because you guys, I think it's so much more for you guys to be working on a real application, something that's really a problem in the industry, rather than some out of a book or something. So that's what attracted me to it. And Josh was keen. So I will not answer any of that anymore. I'll leave that to Josh if you want any more information on that, because that's all I know really. But
So yeah, submit the coursework, and if it's any good, sell that idea to GK.
But all I'm asking you to do is measure a few screws in it. I'm not asking you to give a complete solution, am I? It's a measure a few grub screws. I think you'll get the paper and measure a few grub screws. But anyway, it's brilliant. The application is good. Now, I know that you guys have not gone down to the lab, so I don't know what I can do to motivate you down the lab. There's this fantastic driving simulator down there, right? I saw some guy getting thrown around in it. I'm not going to get in there myself, as you can imagine, but if anybody's into that kind of thing, I dare say if you speak nicely to Andy, he lets you go on that.
Can you just remind me where it is again, how to get there?
Very easy. Yeah, you're coming through the main entrance to Z Block, aren't you? Come up the steps, you're walking along past the staircase, you keep on walking, there's an RP lab, you go through that RP lab, and then you're on top of the staircase, looking down on the digital gallery. It's on the ground floor, lower floor. It's in the lower floor. So, but to get through that door, you might have to, it does require a swipe card, so that's why you want to.
Well, it didn't work when I went there last week.
No, you probably won't get to that door. That's a slight problem.
It requires a swipe card, not our swipe card.
Probably. I'm just guessing that's the case. Yeah. So that's why I tap on the door and let you in, I guess. He's probably pretty good. He's there all the time. He's a bit of a character. Real character. I mean, yeah. But he lives in a what do they call it?
The digital gallery.
Oh, well, you think so? Yeah. As far as I can see. His wife. I bet I'll go into details of this, but he lives in a what do they call it? Narrow boat in Bristol Docks. So yeah, but in a nice way. Yeah, he's probably the kind of guy. I mean, he's sorted it all out for you basically. But so I don't know what I can do to motivate you guys to get you down to Digital Gallery, but what about low quality street? Sorry, ring them up down there.
Oh no, it'd be nice if we could touch our key card against the door and it opens. That'd be great.
Well, don't ask for the impossible. No, I know what you mean, but it's lucky I don't have any influence on what people would listen to me if I asked them to, probably. I could suggest it somewhere, that you guys could get in there with your swipe cards. But I don't know, Andy's the king of down there. I don't want to step on his toes. You can probably talk to him about that. Yeah. I'll ask him what's going on with that.
So when we're taking the photos of the screws, do we do them all from the same angle, or do you want mixed up angles?
Well, if you read what in the Simon Handout, it says it wants the axis of the screw to be perpendicular to the axis of the camera to avoid parallax. If I start presenting the screw, if I'm looking down with the camera, start presenting it at some kind of angle, then that's going to appear shorter than it is.
Okay, yeah.
So, but then again, you want a very rotation, because it could be presented make sure it works.
So the angle got to be out the bar and the screw's got to be flat. That's to the right angle, but it could be 360 rotated, not a metal plate.
The way it's set up, there's like a metal frame which the camera's attached to. It's obviously you can't really get it wrong.
That's it. So the backlighting thing.
No, what I will say is that when we went down, the screws were out of focus because the camera's too close. The screws are back, so you can adjust that one.
I couldn't be that well. So
It's
got a slider on it as well to adjust the, which I think is the amplitude to get the right to the
I used to have it.
only there by 15 minutes.
My mum's got it, she refuses to give it to me.
you learn more about
Well, yeah, she just has the ones that are eight that you have to see exactly.
You zero it on the, and then it pushes down.
If I went tomorrow, just to say, and I've got the photograph, level skills are not quite there yet. Is that how you expect them? And then we get going on it, or?
I mean, let me stop these guys in industry. actually the really, really intensive analysis of them, you probably wait for it. So it's not stopping you about an image. This is so good. This is actually the first time I've actually done it. That's part of the assignment.
First time you've got equipment.
Yeah, up to now, it's hands of instruments and like that.
So it's important for you, for us to learn the skills that acquiring the images is part of it.
So, machine vision is supposed to come out, just cameras and things like that.
Well, that's really right.
Still a man.
It doesn't matter.
So we'll get Mark.
You are
I mean, all of our images are out of focus and the lights will get less marked, whereas if we've got good quality photos,
Senior years, you could like select the man.
I suppose it doesn't really matter if you programmed it well enough that it could work out the levels of bad quality images that would be better.
Yeah, but there's this conceptual and to do some further processes, get the best possible image.
Oh yeah, I would make it easy for myself.
I think it's pretty self-explanatory. I think you particularly want clarifying. Drop the
Anything produced during
Yeah.
the is owned by the
Right, brilliant. Yeah, as I say, I think the handout is pretty self-explanatory, just saying. But if you do get any specific questions, just drop me an email, or you can come and see me. Have a chat.
No, last week we did do like a little taster thing on the lab view.
I did it.
Oh, you did?
Because I knew I wasn't going to go, so I
You went to like
emailed her and recorded it so I could.
You make use of micrometers.
Yeah, I was doing a little bit at the end. It was like,
Oh, wait on
the
the
panel which is the lights.
yeah, because I was like, I could do this panel, but
See, the idea of this
Oh, where about the
yeah,
go
yeah,
beyond
I
what
can do that really good today.
the robot will take the rubber out. It will present it to the camera will work out what size it is. Then it will put it, screw it somewhere else. I'm just thinking.
I feel like that robot arm could have a wing set player out, and it would be done. And then it would just take it out, it would go, as opposed to going with the camera and then putting it away.
Look,
So Josh, you do
I'll do the course.
if you're a robot application, you've got something in there, you take it out, you put it on downside. That is a nightmare. You've lost, you've lost your orientation of it, and you're screwed.
like a potentiometer behind the
That's most of the time. If I know that I need to use a piece of universal, I'll come in and I'll use
It's the same thing. This is a machine vision.
Yeah, the whole point is.
This is engineering degree.
Look, yeah, he wants to know.
The solution right.
This is exactly what you made in
a strain gauge type thing to weigh it on the end of the robot.
I had someone at the beginning, I was going to unscrew it. I prefer to just
This is the exact opposite. We're trying to automate a fail-safe solution. So look, at the moment they got that going on, they got everything's getting mixed up and everything's going wrong.
It could get extremely complicated. We're just doing the imaging, like you can do pretty much any type of modelling at all. So you've got good at it.
No, I mean, I'm quite keen to learn how to use it better because it's so like basically like dragging items and dragging wires, whereas like Python or C++, like lines of code and stuff, I don't know what
Also, giving my dog back.
Click and drag a light over there. Click and drag a
That's what it's still not as easy as you
I don't know what you're talking about. 3 minutes? 2 minutes? 3 minutes? 2 minutes, I think.
All of these fasting
Hold on, no, we've got 2.5 hours.
orientation.
So this looks less than a normal
Going to
We'll get the train to Cardiff.
So just where that place is.
On the outside there. Ground floor, if you go, come in the front door, down, steps and then turn left next to the elevator. Like literally right in front of the front door, and then turn left.
That's just down there.
Alright, well, unless you have any questions, I'll see you all next week. We've got to have a space age robot over here that's raising, and we don't need vision.
Nice to see you.